This is the final video for Chapter 1, Section 4 of your McGraw-Hill Geometry textbook. It will cover the final term in the section, which is the term angle bisector, and then we'll have a couple of examples of how to use that term. So, an angle bisector is a ray which divides an angle or cuts an angle, same thing, into two congruent angles, two geometrically equal angles. Now notice these arc markings here. Those arc markings tell us that these are congruent angles. So in other words, we have angle ABD is marked as being congruent to angle DBC. Can't remember earlier if I pointed out this symbol. This is the symbol for congruent. Looks a lot like equals because it is a lot like equals. It's not exactly the same, but it's very, very similar. Okay, and that tells us that ray BD is an angle bisector of the big angle in that picture, angle ABC. Alright, let's do some examples. So, ray BD bisects angle ABC. If the measure of angle ABD is 3x minus 7, and the measure of angle DBC is 2x plus 8, find the value of x and the measure of angle ABC. Alright, so let's label the picture here. We have measure of angle ABD is 3x minus 7. And we have the measure of angle DBC is 2x plus 8. Notice how I'm writing those measurements in the interior of the angles. So that's how I would label it. Now, if BD bisects angle ABC, then that means that angle ABD must be congruent to angle DBC. And if they're congruent, then that means their measures are equal. So we plug in those expressions. The measure of angle ABD is 3x minus 7. And the measure of angle DBC is 2x plus 8. That's an equation which we can solve. So we're going to move the variables to one side. Let's say we subtract 2x from each side and the numbers to the other. So we'll add 7 to each side. That will give us the value of x. X is 15. Now again, we need to be very careful. It needs to be part of our routine to make sure that we've actually answered a question when we think we're done, because we're not done yet. We found x, but that's all that we found. We also have to find the measure of angle ABC. Now we don't know the measure of angle ABC yet. So what we have to do is we have to find the measure of each of these individual angles. So 3x minus 7 would be 3 times 15 minus 7, or 38 degrees. Now, they're marked as being congruent, so we should also know that 2x plus 8 is going to equal 38, but we could just as easily plug the 15 in down there as well. That would also give us 38 degrees. So the measure of the large angle, angle ABC, is the sum of the measures of the two smaller angles, or 76 degrees. Let's do another one. Alright, ray BD bisects angle ABC. If ABD is 2x plus 5 degrees and angle ABC is 7x minus 20, find the value of x and the measure of angle DBC. Now if BD bisects angle ABC, then we can plug in this 2x plus 5 here. Now they didn't give us a separate measurement for angle DBC, But this word bisects tells us all we need to know. That means that this angle is also 2x plus 5 degrees. Now, the problem with that is that that's not going to be enough information for us to solve, because we can't do what we did in the last problem where we set those two things equal to each other. What we have to do instead is we have to realize that ABC, the big angle, is exactly twice as large as the measure of angle ABD. This would be because we have two different angles of this measure that make up the entire big angle. So we plug in what we know. ABC is given in the directions as being 7x minus 20, and ABD is 2x plus 5. So that gives us the equation 7x minus 20 equals 2 times 2x plus 5. To solve that, we would distribute. That would give us 7x minus 20 equals 4x plus 10, distributive property from algebra. Then we would move the variable to one side by subtracting 4x from each side and add 20 to each side to move the number to the other side, just like we did in the previous example. That would give us 3x equals 30. And then we would divide by 3 to get x by itself. And that would give us that x equals 10. Now that's the first part of our answer, but we also need the measure of angle DBC. Well, the measure of angle DBC is the same as the measure of angle ABD. So that would be 2x plus 5, or 2 times 10 plus 5, which would be 25 degrees. That does it for the Section 4 notes. I hope these videos have been helpful. We'll move on to Section 5 in the next video in the playlist.